GraalVM can compile your Java applications into native images. What are the benefits? The native images already speak the language of their host systems. They do not need further translations or interpretations. So, one of the main benefits, your applications are more efficient. But there's always a but. Native images could pose debugging challenges, such as how would you trace and isolate specific code segments in binary files? Then there are other concerns, such as does the GraalVM native debugger support all operating systems? What about remote debugging? And perhaps the most important question, what can Java developers expect? I know these are a lot of questions. I don't have answers to these questions, but don't worry, our speakers today definitely do. Hi, everyone. Thanks for joining for another episode of IntelliJ IDEA Livestream. I'm your host, Mala Gupta. And now let me add our speakers to the stream. Dimitri, OpenJDK committer and speaker.
Hi, everyone.
Hey, Dimitri. And Anton Aripov, my colleague at JetBrains.
Hello there.
It's a pleasure to have you both today. How are you doing?
Perfect. We're pumped to show some fun stuff today.
Looking forward to it. So, Anton and Dimitri, before I let you take the stage, I have a quick question for you. What is the most common complaint that you hear from developers about debugging their native GraalVM image?
Because it's a hard topic. It's hard to debug something that is very native and not Java and not running the Java bytecode. And this is what the session is about today.
Yeah,
So, yes,
the complaint is like, it is so different.
Yes, I can imagine that. So I'll not take a lot of your time. And before I let you both take the stage, let me share some quick housekeeping details. Everyone watching, please use the YouTube chat to post your questions. We'll answer your questions as you post them. And the session is being recorded and hosted on IntelliJ IDEA's YouTube channel and also Twitch channel. So if you haven't already subscribed to our channel, now is the time to do that. And if you like today's session, which I'm sure you would do, please like the video. And with that, Anton, let me add your screen to the, okay, it's already there. And with that, all the best to you and have fun.
Thanks, Mala. So, folks, we're gonna talk about GraalVM native image debugging in IntelliJ, of course, and this is a fun and geeky topic, and we would like to demonstrate something that is actually a work in progress. So you wouldn't find this in a stable version of IntelliJ IDEA right now, but if you go and install the EAP early access program version from the JetBrains toolbox, then you will get this version that I'm running right now. So if I open the ID information, I want to highlight this. It's IntelliJ 2025.1 EAP, and it's built on January the 30th. We actually had some fun today figuring out what is the state of the feature in the nightly builds, but we decided that something that is a stable public build that you can download today is more appropriate for the session. So, I made a small demo, reasonably small, so that we could actually pay attention to the essential details of the whole process. And Dimitri is actually this expert here who knows the runtime, who knows the details about the debugging, and I'm just pressing the buttons and asking the stupid questions. So with this little demo, we're going to start by explaining what it actually does and how I created it. And then we start debugging and see the intimate details of the tooling that we have here in front of us. So Dmitry, I'm going to tell you a story, how I created this demo application, because I'm learning about GraalVM native images today, and it seems like a fun topic, and I'm quite excited of what it offers. But I'm also just an average Spring developer. So how could I create an application like this? Obviously, by opening Spring Initializer, start.spring.io, the favorite place on the internet for Josh Long, as we know it. And if you add the dependencies to a stock application or like to empty project, you can see there is GraalVM Native Image support, right? So if we add that and explore what is being added, let's do it with Maven today. You will
Thank you.
you will see this plugin being added to the configuration, right? So we basically can generate an empty project for Spring with pre-configured GraalVM native image support. And this is where I started. So I created this one. And then I added a few components into my application. So I currently have a few endpoints in a web application. The first one is at the root endpoint right now, and it iterates over the pangrams. Do you know what the pangrams are?
Yeah,
I just learned it today, so.
So anyone should probably already spotted them.
Yeah, like the quick brown fox jumps over the lazy dog is the famous phrase for testing the font types, as far as I know, right? And there is more. So I just have an array of predefined string constants that I'm going to somehow access either via the index at this endpoint, and I have another controller that I called unconventionally a little bit pangram rotator, accessed over the different endpoint, and it just rotates over the array, accessing the first index, the second index, the third index, and so on. And I also have I've been experimenting, of course, and I've been experimenting with reflection. And I have a third endpoint that accesses the same array via the reflection. I'm not gonna spend time on this one, so we're gonna focus on these two controllers today.
Yes, and by the way, maybe someone doesn't know that reflection works in GraalVM Native Images.
Yes, and we're gonna explain how it works. We have I have a configuration. In fact, this project is hosted on my GitHub account, and I'm going to add the link later into the comments as well, so that everybody who is on the stream could try it out and play with the same setup, and maybe download the EAP of IntelliJ IDEA and try debugging this application as well. So I have imported this project, added the configurations. If we go to the pom.xml, we're gonna see that I actually read the documentation and added this configuration block with additional build arguments. It's a pretty long line. Let's not scroll like till the end because there's so many different arguments. But the point is that there is this image name that is created, and it will be the binary that I'm going to execute. This is the native binary. If I go to the terminal.
Otherwise, by the way, it will be derived from your artifact name.
Oh, nice. I didn't know. I thought it's the mandatory configuration, and I was surprised that it wasn't added from scratch, but nice. So I actually pre-built it. So I already have this binary. It's in my target folder. And if I check the file type of this binary in the target folder, pangrams, that's the binary. You see, it's a macOS native executable. Cool. So now everything that is left for me is just to run this binary. And it starts like almost immediately, as you can see. Let me kill this application again, and just for everybody to see how quick it is. Boom.
Yeah, it has some time reported.
Yes, so it's like less than 1/100th of a second. It's awesome. Even though the application is small, but imagine it's the full JVM starting up. So now we can actually open the browser tab and see what does the what does the application respond when we access those
Yeah, and
endpoints.
here you see all the properties are supported, so you can tune the port or whatever. So we have the same application, but just it has been compiled into a native image. By the way, have you shown the command line, right? So you need to invoke a certain command line to have it compiled to the native image.
You want to compile the native image?
Yeah, just if you have
I thought
command line around.
just to show how the application works first,
Okay,
and then we're gonna build it. So this is the root endpoint, right? So the pangram controller it accesses this hello, and it's gonna select some random string constant to display it along with the timestamp. And we can see the timestamp doesn't change. That's fine, but it doesn't match the timestamp that I have on my computer right now. So it's
well, the actual
hours.
time is yes.
Yeah, my actual time is like because of my time zone is 17, like 11 minutes after 17, it's like 5 p.m. And it looks like I have built or the image is from 2 hours ago, or like the timestamp is from 2 hours ago. And if I access the other endpoint, rotate, it looks like the timestamp that I had 2 minutes ago, 2 hours and 2 minutes. But let's look at the source code.
And
The source
yeah,
code,
let's look at the source code. Probably it's just written there. So the timestamp is
and
derived from
timestamp
some string.
here, right? So that's the timestamp that I have on the root controller 2 hours ago, and the rotator is the same field declared in the same way.
We just have a timestamp, which is initialized in like as a class, as an instance field in this bin, right? This is
Yeah,
2 bins, they are controllers, and
two
the code
bins.
looks exactly the same.
Yes, and even the method that prints the timestamp is just exact copy, because I like copy pasting my programs right here, right? What could be the issue? Definitely something is with initialization, but how come the same code is different? By the way, we can make a test and run this program as a Java program. Let's try it. Let's kill the native image right now and run the Java program.
So can we make one more experiment? We can restart the native image. Oh, you're already rebuilding, right?
Yeah, I'm already running the app. So,
but that really looks like a mystery, right? We have the similar code in 2 controllers, absolutely similar code,
and then
it just works
back
differently.
Oh, but now it works exactly the same.
So is there a bug in the native image itself?
Right. So in Java program, it behaves one way, and in the native image, it's different. How come?
So any suggestions are welcome in chat. Let's think about it together.
So how could we rebuild it? Well, I didn't show how to build it, right? Let's stop the application. And building this is very easy. I select the native profile, and I just run the package goal for Maven. So if I just do the double click,
So it totally makes sense, right?
Start.
It's a compilation, but the compilation of the native image.
Let's try that. It's gonna take. I think it's gonna take about 2 minutes or maybe 1.5 minutes. But yeah, it runs the tests. Let's see. Okay. So I'm building it on my machine right now in this directory. It's actually fun to watch how it progresses by looking.
We have seen some interesting output. It says that -G is not supported on macOS, which means it's probably not the library connect build. So we use stock GraalVM C build here, which doesn't support debug information in macOS.
Okay, that's GraalVM C21.
Yeah, and today's session is like about debugging. So we still will be able to debug it, and we want to figure out what happens, right?
Okay, it's about there. Okay. But what else could we see from this log? We can see a lot of different properties, like different resources being added to this image. This is like a common line, right?
We can repeat the experiment, right? We can look how the application works.
Okay, it's almost ready.
Yeah. Probably the most heavyweight phases of the compilation.
Meanwhile,
do we have any suggestions?
Yeah, I wanted to check if there is someone.
Let's debug the timestamp. Oh,
that's a good point. This is what we are about to do, right? We're gonna debug this timestamp.
Dependencies loaded differently. Yes, but which dependencies? We only create a timestamp, right?
Okay, yeah, we now have this native image, the new version of it. Let's check if that's the correct binary, right? It should have an updated timestamp on the binary itself. First of all, no magic. So
yes.
17:17 is my time, exactly the same minute. We're gonna run this program. Let's wait until it's 18 minutes. I hope.
Yeah, I'm reading the chat. Good suggestion. The timestamp is a static value, so it gets initialized when the class first gets loaded and never changes after that.
That's it.
You saw the difference. It's
well-educated
2 hours difference, right? So
yeah. So let's see. We have 17:17. Currently on my machine, it's already 17:18. So there will be at least 1 minute difference if it still works the same way as previously. We have rebuilt the image, right? We are running the image now, the application. Actually, the first run after the build is slightly slower, but still fast. So the application is now running. Let's go to that entry point now and see what will it be, 17:17 or 17:18? What do you think?
Yes, I see a response from Alan. That's not a guess. It's because the timestamp code is executed at compile time.
Okay, you see,
we don't have that 2 hours difference anymore, but definitely looks like
it's 17:15. But if you go to the other endpoint, it's 17:18. So this one is definitely the time of the application start, and the previous one looks like it's the application build, right? What could be the issue? Let's actually start debugging. How could we debug a native image, Dmitry?
Yes, in this case, we have a local environment that doesn't support debugging, and even if you would have some debug information on macOS, unfortunately, that would not be sufficient to have good debug experience as it can be at the time. So if you can see a few slides that I'm showing.
Yeah.
Unlike traditional Java programs, native images are native programs. So their debugging information is in platform-specific native debugging format. So for every platform, it has its own debugging format and debug information format, which is embedded into the native executable. And by the way, if we provide and deploy or create Java code, we usually, like almost always, embed debug information in there. When we build a native image, we have to instruct the compiler to include this information. And currently, only like Linux platforms are supported the best, so they contain the most complete and usable debug information. And there are debuggers that can interact with such binary and let us to debug it. And if we are on a kind somehow alien platform, right, macOS or Windows, we can do the same as what we do to have reproducible environment and closer to production environment. We can run in containers.
So are you saying that I would have to use Docker for debugging my native image?
Yes, I would propose to use Docker. We can use any other container management system as well. We can use Kubernetes, we can use Podman, but probably that's the simplest solution for now. And in any case, even if you run locally, even if you would have a local Linux development environment, right? You still can do it, and you'll still have different components while you debug, different components of your debugging story. So you have to compile all your program with debugging support, right, and derive some sources. And here, if we use the help of the IDE, we don't need to think about deploying sources or getting them out of somewhere. We just have them right with the IDE. And the debugger embedded in the IDE can easily link all the sources because they are already there when it gets some debug information from the target. So our target is a container, a machine, or whatever, maybe the same machine, that actually where our target binary is running. And we have derived some wide set of information bits when we created it. So we need sources for debugging, we need the debug information, and we need to connect to that binary. Sometimes we need some extra, like we have to run some management software. It can be, if it's a remote party, it can be a GDB server. And why it's GDB, why I mentioned it specifically, because we got to a point where we need some Linux containers to run and debug our application, our native image. Probably it will be deployed as a Linux binary, either for x86 or R64. And we're going to compile it in this way. So we need a build time container. So we take all the build tools, we assemble our application in a container with the same target architecture as the debugging target machine. And we will run the result in the target container. And as it's a Linux debugging process, we will have a GDB protocol. We will exchange in IDE and some backend in that container, GDB server. We'll exchange debugging information and control how application is being stopped and how it continues its execution according to commands from our IDE, right? That's what we are going to achieve.
Sounds like there is a lot of moving parts, or let's say a lot of components that should interact together. I guess we can switch to the IDE now, right?
Just I want to probably show one more slide about. Oh, yeah. Let's switch. Let's switch.
Okay. All right. So what I learned now is that the native image that I have right now on my machine built for macOS would not be suitable for debugging in the container. And for that, I actually need to build the Linux version, or I have to create or run the build inside Docker container itself to create the native image that is that is good for debugging, right? So it means that my
And it sounds
Maven
like a typical
goal,
task, right?
yeah. So the Maven goal that I just executed, the package one, it should run in a Docker container. And if we check the run configurations and edit one, we actually have this target selector, which is by default the local machine. And normally you run stuff on local machine, but you can manage targets and add more images or more targets, not only the Docker, but also Docker Compose, SSH. There is one interesting option that I haven't tried before. I don't know what it is, but Docker image is what we are looking for, right? So I have two images.
Yeah, so you already have that configurations, right?
Exactly.
So
all I need to do, and by the way, like if you wanted to know how to create them, you could just select Docker and add the image here. How do I know which image to add, Mitri?
Yeah, that's a great and a tricky question at the same time, because this is a functionality being developed right now, right? So some requirements are changing, but at the time, you can pick some universal image that is able to run the native image compilation, that is able to run the native image itself, and which is able to run and contains your build system, like Maven. The Maven is required for now. And yes, you're showing the set of images that we started to provide. So we have the downstream distribution of GraalVM, which is called Liberica Native Image Kit, and we provide ready-made container images for it. Yes, and you see here, you can search for debug images. And for that debug images, there's a plethora of different images, which basically have some base JDK version. They have base GraalVM version, and also two possible flavors, Chilipc and Muscle.
And different architectures as well, right?
Yes, and you can use either x86 or ARM. Which is convenient. You just select what you need, but you have to paste it here.
Right.
For now, it works like this.
So if I just pasted it here and I clicked next, and it created the run target configuration for me. Now I have two of them, so they are predefined here for me. I actually created them before. I will not download a new image. Instead, I will just select one of them, this 21 Nick whatever. And now if I run this Maven goal, again, it will actually run Maven build, creating the native image within a Docker container.
Yes, and note, it will combine some resources from your local machine, right? It won't like silly create files inside the running container, right? Some volume will be used. And if it was a debug configuration, the necessary build time flags for debugging will be added. And for anyone who still follows the original story, we're trying to build and debug the application where we have spotted some strange behavior. So
Right.
we still have this long and probably
So
complex
our
initial step.
goal right now is to start a debug process with a native image and set a breakpoint and inspect the application. There is a good question in the chat. How do I know that the build is running in a Docker container? This one. So by looking at the build output, I can actually tell it's indirectly that the file path or the directory path that I can see here
Yes.
is user lib JVM liberic canic whatever is definitely not located on my system. It must be something else.
Yes. So this container derived from the container image that we're seeing. It contains the compiler, it contains Maven, and the application sources are attached to create a running container, right? And we compile everything in that running container, and we have that.
So now the binary that I
Sure.
just created, we can see that it's not a macOS native binary, and I wouldn't be able to run it on my local system. Now I need to run it in a container as well.
In a
And actually, I
container.
will have to create a run configuration for that. I already created one. Let me demonstrate what it is. So there's GraalVM Native Image configuration that you can create from this drop down. This one, it actually by default it creates a configuration with the build tasks. So it will run the build before running the binary, but I have created a copy of that without the dependency on the build tasks because we already have the binary on my file system. And
Yes,
only
and
thing
don't be afraid to delete that tasks. Just
it's totally fine.
not scary.
So I have selected the same target, the same Docker image that I have used for building, and then the executable is pointing to that executable that is in my build folder, along with the symbols, debug symbols, right? The pangrams.debug, and then I have to select the class path module for this.
This is an interesting
configuration as
detail.
well.
So it's still kind of GDB like sources attachment, right? So we say,
Exactly.
okay, this is the place where we'll be pointing, where we'll be taking sources to point, where we get some debugging places, getting them hit.
So our point right now is that we have two static fields in two different controllers. Actually, they are two different fields with the same name, and our point will, first test will be to hit the initializers of both fields on the start, because it's a Spring application. It's going to initialize them on the start.
So you can breakpoint there, right? It doesn't look like a normal code, but it is.
Exactly.
It actually is a code of a method. As we initialize the class, we run this special method. And this is a statement that is actually a part of this method.
So let's run the configuration now in debug mode.
Oh, nice. Side by side. Yes.
Yeah, we're gonna see they should hit both, right?
So we initialize both at bins at the application startup.
By the way, one thing that is not very different, but is different from when you start the application, just normal Java application. Normally, you would see something like the threads variable console, but there's two more tabs: the GDB and GraalVM on Docker console. So those are additional tools that we get for debugging the native images. Look at this. We have hit the pentagram rotator breakpoint. Well, it
Yes,
is
maybe
initialized.
it just was the first.
Yeah, maybe it is just the first. Okay, and we are waiting. And the application
Right.
is already started. And
It is just running.
the one on the left didn't hit.
So we know that this initializer hasn't been executed while it has been executed. So
There is a value. There is a
had been
value.
executed somewhere before we started debugging.
But this breakpoint didn't work. That's interesting,
Yes.
to say the least. But let's set a breakpoint. Let me switch to one window so that everything fits on the screen, and open the controller that currently works correctly. We know that it hits the breakpoint on initialization, and set the breakpoint into the endpoint method. So if we go to the local host and access that endpoint, we actually have to access it via
the
this.
different port.
It's not a local one, so I have to bring it from the. Sorry, I have to bring it from the other screen. Yes.
Yes, and by the way, here you see we don't use any port forwarding for this container. It just runs. So that's
exactly
what IDE can give you.
So
or you can do it.
Rotate. That was the correct endpoint, and it hits the breakpoint during execution. So let's step over. See, there's something different, something unexpected for the Java programs. Normally, you would get a value, but here we have some sort of an address in memory, it looks like. And we can browse the internals of this array, and we can see all our strings that we have hard-coded into the application. Okay, so if we step further,
which is already a way nice experience than GDB.
Right. So we are stepping over the sources, but actually we are debugging the native executable. Step into. There's the formatter that will format the date timestamp for us. And then we can select this expression. It's evaluating. So expression evaluation also works. And this normal expression evaluation also works here.
Yeah. What about the locals? Let's look at what values do we have here.
We have the formatter. We have, this is the work in progress. So sorry, folks, some of the things will throw an error. And the timestamp field is the one that we are interested in. And it does exist, right?
So it has been initialized and it's available to us in this debugging
in the native
session.
memory. Let's do the same for the other controller that didn't work properly that we are trying to debug. So I'm going to let this run. And one little thing that developers showed me a few hours ago. That's going to be fun, and Dmitry, you will like it. Let's execute this again. Step a few times, and then call this action disassemble.
Yes.
Wow. Those are the assembly.
This is the code that's much easier to read, right? It's simpler.
This is the code that is actually executing. So the code on the left is what we see and what we are comfortable to work with. But the one on the right, this is what is being executed. So if we start stepping over the instructions, we will see that a few instructions pass by and just one line steps over on the left. And if we step over on the left, we can see that multiple instructions are skipped.
And what's even better, the stepping on the right in the disassembly is sequential. So it's predictable and sequential, and for the corresponding Java sources, it won't be always sequential and expected just because of the way compilers work.
Okay, so let's go into this problematic place. So this is where this timestamp should have been initialized. It was initialized presumably, but we didn't see how it was initialized because we didn't hit the breakpoint. So what if we access that application right here? It hits the breakpoint. There is this formatter now. Let's try to evaluate. Yeah, what about timestamp and no such static field? Timestamp. How come?
So we have it initialized. Everything works, right? We don't have any exceptions, seg faults, whatever. The code works, but the initializer.
And in watches, I can actually find that, right? I can actually see that IDE recognizes this field. But what IDE sees is the source code. And if we try to get the information from the runtime doesn't have this field. So the field is missing. There's no such a field in memory as the program runs, but the application runs and returns something which is kind of incorrect value. Can we inspect the shape of the class somehow, right? We have those two extra tabs, and one of them is where the dragons are. Let's see. There is a log, and I'm not a native developer, but I can probably guess that if I want to use this, I have to stay on the breakpoint, right? So I have to execute it once again.
Yes.
And there's this interesting this. What does it do? It gives me some information about the context, right? And I'm currently in the pangram controller class, somewhere on some line. On line 24, I guess. Yes, that's the breakpoint line. And now, if I wanted to inspect, there was a command to inspect the shape of the class, right, in the GDB. Do you remember that?
No. So it's like type.
P type.
No.
Okay, let's see. Boom. There is the information about the pangram controller, and if we look at the members of that class, we can see the formatted timestamp. We can see hello method, which is the public one. We can see some public fields, but we don't see that timestamp field at all. And if we inspect the other pangram rotator,
and by the way, it doesn't look like a C++ class. It is encoded. This information is encoded as information for a C++ class.
Right. And we can see that the other class actually has this static field information. So we can confirm now that our program, the behavior of our program is caused by the difference in the I don't even know. Should we call it a bytecode? It's not a bytecode. It's the representation of the class in the native image.
Yes.
Right. So I guess this is what we wanted to show, but we still didn't reveal how did it happen.
Yeah. So we've got the correct answer in the chat, right? So this is because of the build time initialization. So we already see that this timestamp that we constantly have unmodified while the application is running corresponds to the build time of the application.
So
it has been initial. Let's look at the log, right?
Let's look at the build log. Yeah. So how could it be? How could we find? What should we look for? What do you think?
There's a lot of information. But basically, GraalVM compiler reports some build-time initialization to us, and the build log will contain all the options that we have
in the
that we had as a combined set of options and settings.
So, where could it be? Is there a string that I could look for? Maybe looking at the pom.xml would reveal something. Okay, there's this -g.
Yes, and by the way, here this -g is not necessary because this is for manually building debug version of the native image. And if it's built by the IDE, IntelliJ IDEA adds this flag for us whenever it's built in container or it's built on the host, if the host supports
look at this
version. Yes, we see it here.
Class initialization, the class name, and it says that it's gonna initialize that at the build time. Why would anyone do that, Dmitry?
Of course, it's very useful. It's we don't need to repeat some initialization if we know that compiler can't detect it as. I think that we are allowed to execute in build time. So this is a great optimization in general. So many things that are proven to be safe to be initialized at build time will be initialized at build time automatically. But here we enforce this initialization, and we see why we have to enforce it, because it leads to such unobvious effects, because it's not safe. But yes, it's a timestamp, so probably someone, a previous programmer, wanted to leave a build timestamp in the code for us, and that was an elegant way to do it. Just say, please initialize this class at build time, and it's only a configuration, no changes in code. Maybe it's even some methodology, I don't know.
So it might be a feature, it's definitely not a bug. It's just the way things are, and you can control how you assemble the native image and what should be initialized at the runtime or what should be initialized at the build time. And kind of the same story is with the reflection we mentioned in the beginning of the session, that there's reflection configuration, and this is the file that you can compose manually or by running a trace agent. So have a first version of the trace of the native image assembled, and then enable the trace agent and collect this information about reflection calls automatically for you. This one is a minimal configuration for my use case. So currently in this reflection controller, I'm accessing the pangrams class by just accessing or calling out the method. So the method comes as a dynamic parameter with the request. And the configuration looks like this. All the methods are listed for the class that should be accessible or should be available or configured for the reflection. So currently I have 9 of them configured, and 1 of them is not configured because I wanted to show what happens if you access a method that is not configured for reflection access. So the endpoint that I have, let's see, the reflection controller. Here's the reflection, matching this access point, and method is going to be zebra, that is not configured. And you will see the error, but in the command line, we will see something else. We will see, yeah. So the program tried to reflectively invoke a method without it being registered. So if I just mistype some method that is not existing in the class, there will be another method missing. But here the method exists, but it's not configured for reflective access. this time. So that's just a fun thing. It's not related
Yeah,
to debugging.
that's a special native image behavior. So it allows you to continue running. It just says, well, you're not
Exactly.
configured enough.
So what we did, we demonstrated how the build time affects the behavior of the application, right? The build configuration even. Right? So we forcefully initialized the one field, what was the timestamp, the one in the controller class. It was initialized at the build time. The other one was not initialized at the build time. It was initialized at the startup time. So therefore, the difference in the behavior of the application, the behavior of different controllers.
Different endpoints.
Right. We have now multiple complex components within this process. We have the IDE that is the front end for you as developers to being able to step over, inspect the variables, and so on. But underneath, there is like a ton of interesting dragons, I would say, the GDB, Docker, and GraalVM Native Image running in Docker. So our task and our work in progress today is to supply a good developer experience to you when you actually need to debug such images. It's not something that happens very often, but well, might happen accidentally. Like in this case, someone just configured the build time initialization for a field and you did not expect that, right?
Yes, and we've just seen one of these scenarios, right? So we have seen the scenario where we run and debug the container, but there's also a possibility to perform an attach. There are different ways to connect to that container, as Anton has shown.
So there were a few other options in the build. Dmitry, do you want to cover them? Like, do you want to?
I just wanted to show a few useful ones when you work with debugging. I think that's important. Just
Okay.
show if we can switch to my screen here. So we have seen first of all the major one, right, which is added automatically, or if you perform somehow manual command line debugging, you can edit yourself. There are different optimizations level, and the harder is the optimization strategy, the harder is to link the machine code to your original Java source. Unlike traditional JVM, many things can be optimized and reorganized in a way where the link is just hard to follow. So O0 means no optimization, which makes the debugging easier. Like in our case, it doesn't matter what level of optimizations do you have, and the build time initialization happens in any case, but it can help. And also, you can keep more symbolic information that will improve the experience both in command line debugging and in IDEA. And the options related to sources generations are just needed if you don't use the IDE. So again, having the pieces that work for us.
Okay. So I guess that's all the information I wanted or we wanted to cover today. And we can invite Mala here to ask if there's more questions in the chat.
So first of all, Anton and Dimitri, that was an amazing session. And before I say something else, I would request everyone watching to share their feedback using either the QR code that is displayed on the screen, or you can use the link. We value your feedback, and it really helps us to improve our sessions. And with that, Anton, Dimitri, I don't think we have any other questions left because you both were monitoring the questions during your session, and you kind of answered all the questions But one, I guess people were asking for your slides. So Anton, you would upload the demo code to your GitHub repo. And Dimitri, would you upload the slides to your GitHub repo, or you could share that with us and we could share the link in the description?
Yes, I'll share the link. There are just videos with that slides more detailed. Yes.
Thank you so much. And it was an amazing session. And Anton, as you mentioned initially when you started with the session, that this is not the usual way how Java developers work. So it was interesting how you did everything, starting the images to debugging. The disassembler was amazing. We could see the Java code on the right and the native code on no, Java code on the left and native code on the right. I was flipping the sides. So that was interesting because usually we don't kind of realize what is happening behind the scenes. So that was good to see. That was good to see.
Thank you.
Thank you.
Thank you. Thanks
And
everyone
more,
for joining us.
yeah.
And if you have more questions to us, like you
Mhm.
gotta reach out to us either on the interwebs or
Mhm.
leave your comment on under this video. Why not?
And more respect for the developers now who are working on the debugging of native images. There's one question. Do you want me to? Would you like to take that now? Is by Roberto Cortez, and he's asking how do you handle Graal substitutions in the debugger?
This is a very deep question, Roberto. Thank you for asking that. I guess this is something that Vasily, who is in the chat, is able to answer in details. I wouldn't speculate myself how it's done, but definitely there's some manual hard work mapping the bytes between the native image and the ID.
Technically, I would say this is for platform developers, and it's a special tricky path because there are two sources for some methods in the platform. So the sources of the original sources, which will probably be shown, or the IDE will try to show them, and the sources that are actually used as a substitution, which probably won't be shown, unfortunately, but yes.
Exactly.
That's another level of complexity.
Right.
Thank you so much. And as you said, thanks to everyone for joining the session today. And before we close the stream, I wanted to share that 2 weeks from today, on Thursday, 27th of Feb, we have another interesting session, which is about TDD and AI generative pairing. So that would be an interesting session for everyone to watch. And before I close the stream, Anton and Dimitri, if you have any closing remarks.
Try EIP with GraalVM Native Image and let us know if it works for you.
Yes, please try different scenarios, provide more feedback, and maybe, I don't know, write a note and publish it somewhere. Because there are not too many materials on the topic, which is interesting for everyone.
That's all.
Thank you so much. So until next time, bye-bye.
Bye.
Bye.